All right, this chapter we're going to be talking about what's called matrices. So today we're going to just go ahead and introduce them, just kind of show you what they're all about. Later on this week we'll go ahead and add and subtract and then multiply matrices. So what are we going to do today? We're going to organize data into matrices, and we're going to use row and column operations to analyze some data. So some new vocabulary. First thing is, what is a matrix? A matrix is data represented in rows and columns, kind of like a spreadsheet. Obviously now we have our Excel or Google Sheets, and those obviously work really well in terms of doing data, but once upon a time we didn't have computers to do that, so we had matrix. What's an element? It's a specific data point. The dimensions of a matrix is the number of rows by columns. So we could say it's a 2 by 3, which means it would have 2 rows and 3 columns, or a 4 by 4. It's kind of like setting up your table. How big is your table? You want to say it how many rows and how many columns. Equal matrices are 2 matrices with the exact same dimensions, a 2 by 2 with a 2 by 2. Obviously the insides, the data points, will not be the same, but they will still be the same size. And equal matrices will become important as we go on throughout the chapter. So the beginning part of the chapter will be just the operations that we do with matrices. And then the second part of the chapter, the second week, we'll go ahead and talk about what do we do with matrices and how do they make our lives easier. All right, so let's do some basic dimensions here. State the dimensions of matrix G. Notice how we write a matrix. We have these brackets here. And then the numbers are just put in there. Obviously, like in a spreadsheet, you would have cells that you could go ahead and put them in. But each of these data points are in a cell. Basically, they're an element. And we say matrix G equals, and then you have these brackets. So what are the dimensions? We have 2 rows. We have 2 rows here and 4 columns. Columns, remember, go up and down like the columns on the Parthenon, and row your boat across the stream, goes across. So we have 2 by 4. So this is a 2 by 4 matrix. Now we can go ahead and try to find a specific point in the matrix. And so we can find the value of this should be a G of 1, 2. So that means row 1, so this row here, and column 2, which is this row here. So row 1 is these 4 numbers, and row 2 is these 2 numbers, and where's our intersection? This red number right here. So our answer to A12 is just -1, or G12 would probably be the better way of saying it. All right, what are the dimensions here? How many rows? We have 3. Columns, 2, so it's a 3 by 2. And A12, we don't have a specific value for this, so row 1, column 2. Row 1, column 2 is this 3 value. All right, so how can we go ahead and use matrices? So we have some data here. Caitlin wants to go to one of the Iowa universities next year. Not quite sure why she wants to go to Iowa, but that's her choice. And she has the tuition, the room and board, and their enrollment. So tuition, room and board is for Iowa State, University of Iowa, and University of Northern Iowa. So how do we put this data into a matrix? We have 3 different rows and 3 columns. And so it becomes very easy to go ahead and do this. Now we can go ahead and label them. As you see, this is very much just like a spreadsheet. All right, can we find the average of the elements of column 1 and interpret the results? So here's all the tuitions, and if I average them up, I'm going to have the average tuition to go to one of these colleges. It's not the exact, but it's the average. So I add them all up, divide by 3, and that's the average tuition cost for the 3 universities, around $6,000 a year. Which university total cost is the lowest? Now, total cost would be the tuition and the room and board. Enrollment obviously does not really particularly matter in terms of the cost. So we're going to add these 2 columns together. So we have to do 3 different little equations. There's the first row, second row, and third. So Iowa State is 12,000, University of Iowa is 13,500, and Northern Iowa is 11,600. So northern Iowa is obviously the cheapest. Now we have to understand what's inside our matrix. We can always, obviously they're all numbers, so we can obviously very easily just add things together. Would adding the elements in the rows provide any meaningful data? So if I add all these values coming over here, this whole row for Iowa State University, would that value give me anything? And the answer is probably not, because enrollment is different than this is money over here and this is number of people. They really aren't the same thing. Now you saw that adding these two would mean something, but adding all three of these, no. So you have to be aware of what your elements are. Could you add them all? Sure, but that number that you would get would be meaningless. What about here? Would adding up the third column mean anything? Sure, it would. It would be the amount of kids that are going to school in Iowa this year. So you can add up all of these in those three universities, and they can show it. All right, here we have a matrix displaying Karen's diving scores. Now, if you do not know anything about diving, you get a value for execution, and then you get to multiply it by your degree of difficulty, how difficult was the dive, and that gives you your score. Now, obviously, you want to have the highest score possible when you total them all up. So these are her execution scores out of 10. The degree of difficulty can range anywhere depending upon how difficult the dive is, but normally doesn't go much higher than 3 or 4. So this was a real easy dive, and she did it very well, and so that's her score. But doing a harder dive, a little bit worse, actually gives you a better score. So that's how diving works here. All right, so we have our execution, degree of difficulty, and her score. Find the average of the elements of row 1 and interpret the results. So we can go ahead and add all these up and divide by how many there are. Now, what would that result be? It would be the average of her execution, how good she performed on how well she executed different dives. So the average execution for the 6 dives is what we're talking about. In this case, it's 8.3. We knew it was 8.3. They're all 8.3 here. But which one? It wasn't the degree of difficulty. It wasn't the average score. And then it wasn't the average number of dives. It's how well she executed. The matrix displays her diving. The total score is found by multiplying the degree of difficulty by the execution. Which total dives was the highest? So we'd have to go back to our score here and see which one has the highest score. And this last one, despite the fact that she didn't execute it as well, because we're multiplying by a higher number, she does get a higher score. So it is number 6. The matrix displays, obviously, our scores. The total score is found by multiplying. Would adding the elements of the rows provide anything meaningful? Again, the rows going across, no, because it's a value and then what you multiply and then the total. Would finding the average of the last column provide? Yes, because all the last columns are the same. It would give her an average of how much points she scores per dive in the competition. And that's what I have for you today.